I will prove PV equals nRT given that the average translational energy in the x direction of a molecule or atom in the gas phase equals half kBt. And kB is the Boltzmann constant. kB equals R, the ideal gas constant, divided by the Avogadro constant. So let's imagine we place a mole helium atoms in a box. And we'll look at just one atom at first. We put one helium atom in the box, and we assume that it travels in the x direction at a speed Vx and collide with the area A, the shaded area, bounces back, and another collision, it gets back to the original position. So we can easily tell that after the helium travels a distance of 2L, there's one collision between the helium and this shaded area. What if this helium atom travels within a time period delta t? Well, that means the total distance it travels is delta t times the speed divided by 2L. That will give you the number of collisions between the helium and this surface area within time delta t. In each collision, assuming all collisions are elastic, the speed remains constant. However, the direction changes. So there's a momentum change of 2 times m times Vx. That's the momentum change of one helium atom within time period delta t. We have moles of helium atoms, so if we want to know the total momentum change of all those helium atoms, we will have to sum it up from I equals 1 to, again, this is a number of helium atoms, number of moles times Avogadro constant, and what causes the momentum change of the helium atoms? Well, it's from the force exerted by the surface area. So this is from Newton's law. And by looking at this, we realize delta t on the left-hand side and delta t on the right-hand side, they cancel. And we can simplify 2 and 2. And then we can get more simplified form here. That give you the force exerted by the surface area to the helium atom. And then we do know that force equals pressure times area. And then we multiply both sides by L. You will see on the right hand side we got PV. How about the left hand side? On the left hand side we have a big sum because we're summing I from 1 to the number of helium atoms, but always the sum is a number of samples multiplied by the average. So I'm going to do that. Obviously L and L cancel. And then we have n times Avogadro constant times kBt. That's from this equation equals PV. And then we combine this two, the Avogadro constant and kB. And we have PV equals nRT.